Hi everyone, today I would like to share with you what is causality. Causality can be separated into causal system and non-causal system. A causal system depends on present input, and also a past input. And non-causal system depends on future input. Okay, let's look at some example how to identify this equation is causal or not. Okay, let's say if you have yt equal to xt minus xt minus 1, it is a causal system or not causal system. Okay, let's check. Let's say when t equal to 0 and I substitute the t equal to 0, so y0 equal to x0 minus x 0 minus 1, you have negative 1. Okay, and then when t equal to 1, I have y1 equal to x1 minus x0. And then you check when t equal to 0, y0 equal to x0 and minus x minus 1. So this is the input. So this input is a present. So this is present. And this is past. So exactly fulfill a causal system depends on present and the past input. So this equation is a causal system. Similarly to second example, yt equal to txt. Okay, so when t equal to 0, so you have y0 equal to tx0. So when y1 equal to tx1. So it depends on the present input. So this is also a causal system. Okay, another example is yt equal to x minus t naught. Let's say if t naught is positive t naught, and your output will be yt equal to x negative this is t naught. Okay, but what if t naught is negative? So negative t naught value. Okay, negative t naught value. So yt is x negative t naught. So you will get x t naught. So this x t naught, actually t naught is same as t. So this is you get negative value and this is you get positive value. So the system is non-causal. Okay, do you understand? Now let's look at the example. Now let's do some exercise. Yt equal to txt. Then you will get the answer of causal. Then second is yt equal to x t squared. And this is non-causal. And number third is yt equal to x squared t. Number 4 is yt equal to x sine t. Number 5 is yt equal to negative integration from minus infinity to 4t x tau d tau. And number 6 is yt equal to dxt over dt. The last part of the characteristic of the system classification is the stability of a system. Okay, all the system used for DSP need to be stable. So there are a few kinds of stable system. The one that we will be looking into shall be the bounded input and bounded output. Bounded input, bounded output. We name it as a BIBO. A digital system is BIBO stable if both the input and output are bounded. So what is bounded? A bounded system is any system such that the absolute value of a signal is never greater than some value. Okay, for example, you have a graph like this. So bounded input, bounded output, this means that we have a bound of a and minus a. So this is 0. For example, so the signal will never go through this a and negative a value. So this we name it as a bounded input and bounded output. Okay. What is stable system? Stable system is bounded. So if we want to present in a graph, let's say we have an exponential graph. So this graph is a decay exponential signal. It goes to 0. Okay, it goes to 0 and convergence. Or we can say that the signal is like this. This goes to 0. Okay, this is a decay signal. What about unstable system? For unstable system, it is unbounded. Is unbounded signal. What do you mean by unbounded signal? If you have signal xt and you represent in a graph, this is unbounded, rising exponential graph. This goes to the infinity. And so we name it as a divergence. Or we have another graph, look like this one, goes up. Or a sinusoidal graph, getting higher and higher. So this is a exponential rising that goes to infinity. So we name it as a divergence. This is an unstable system. So do you understand about that? Good luck and thank you for watching.